Okay. Welcome to our 365 final projects. My name is Jack Herberger.
I'm Luke Waltz.
I'm Yu Duong.
And today we are going to be presenting.
Okay, let's go over the project overview first. So the purpose of our database is to focus on the development of a comprehensive sports information database to cater to the dynamic needs of NFL enthusiasts. And the problem we are trying to solve is to efficiently store and manage a diverse range of NFL data, including the team details, player statistics, match schedules, and historical results in a user-friendly format. And the significance of our database is that nearly 185 million fans tune in for NFL games each season, and most of them would want accessible statistics of how their teams and players are doing. So let's head over to the business rules.
All right, thank you, Yu. So these are the business rules we came up with to help us decide how we wanted to model our relational database. And yeah, this is what we came up with. So the first one is the relationship between conferences and divisions. So each conference can have multiple divisions, and each division belongs to exactly one conference. So think AFC, NFC, Northeast, Southwest. Um, so that's a one-to-many relationship. There's also the division to team relationship. Each division can have multiple teams. Each team belongs to only one division. So that's a one-to-many relationship. Team to coach relationship. Each team has one coach. Each coach belongs to one team. That's a one-to-one relationship, but we didn't want to put we want to keep the coach as its own entity, just in case there's like a change in coaches, or if we wanted to start keeping track of like more coaches than just the head coach, then it would become a one-to-many relationship, and that would be a pain if they were the same entity. And then number 4, we got the team to player relationship. Each team can have multiple players. Each player belongs to exactly one team. And that's a one-to-many relationship.
Yeah. So then continuing our business rules here for our player position to player relationship, each position can have many players, but each player can only have one position. So that's a one-to-many relationship. And then for our game to team relationship, this includes both home and away teams. Each game has exactly one home team and one away team. Each team can participate in multiple games as either a home or an away team. So this is a one-to-many relationship for both the home and the away teams. And then finally, for our player to player statistics relationship, each player can have one entry for player statistics, and then each entry in player statistics relates to exactly one player because it's all unique. So that's a one-to-one relationship.
Yeah. So this is our ERD for our relational database. It's all pretty self-explanatory following the business rules we just explained to you. But I do want to address the reason we have this one-to-one relationship between the player and player stats. This will be elaborated on when Jack talks about how he gathered all the player stats. But basically, we used a web scraper to um, get all the player stats into our database, and that was like a long, convoluted process. And it's definitely a lot easier to web scrape into its own individual entity than to try and add it to the existing player table, and make sure it like works with all the existing attributes in there. So we decided, just for ease of use, that we wanted it to be its own entity, and that and though that's not completely ideal, it only adds one extra like join statement to each of our queries, which is not a lot of like overhead. That's not a big deal for any of us. So we decided it was worth it to have them separate just for ease of use, and it's just easier to wrap your head around it.
Okay, so now we're going to jump over to a demonstration of both our database and our web app. I'm going to do the database, and then Luke's going to take over on the web app. So let's jump over to MySQL. Oh, sorry. Get out of here. All right, so let's go to MySQL. Okay, so let me scroll to the top here. So you can see over here, let's just look in our side here. So we have our NFL database. Right here, we have our all of our tables, our coach, conference, division, game, player, player position, player statistics, and then team. So first we started out by creating all the tables, right? So we had to do this in a sequential order, right? Because we wanted to create foreign keys for some tables, but those tables had to be created beforehand. So we started with conference, and then division, and then team, and then player position, and then coach. And then so now that like we had created a coach table, we wanted to alter team to add a foreign key that referenced back to the coach ID. And then we had the player table, the game table, player statistics has all these variables. And then we started inserting all of our data into these tables. So we started with conference. There's only 2 conferences, and then divisions, and then teams. We got all the teams in there with all of their records and all that. And then we just inserted all the player positions. And then we started inserting all the coaches. And then what we did is instead of having to go in and manually map each team ID to the coach, I use these select statements. So I know that this coach is on the Ravens, but I don't know off the top of my head the team ID for the Ravens. So we just did a select from the team ID where the team name is Ravens, and that just automatically puts that team ID into the coach. So that was super helpful. Some more coaches. Had to change this because we wanted to update the team, so we had to take that off. Then game data, again, we did the same thing with the team IDs here. We selected them, use a select statement to grab those, inserted all the games, and then insert all the games. Pretty long file here. More games. I mean, started inserting players. So we have like their ID, their name, I think this is height in inches, their weight, their draft year, and like where they went to college. So we have that for all these players, tons of players, still players. And then, so you can take a look at some of our tables here. So if we go to coach, we can see, okay, we have all these coaches, we have their team ID, we have their coach ID. If we go to conference, we have, there's only 2 conferences, but if you go to division, we have all the divisions. And then say you want to look at the games, right? So you have all the games, you have the away team score, the home team score, and then their IDs. So then if you go back to the queries, so this is where we inserted all of our player statistics. So a big issue we ran into was that we wanted to have the most current statistics, but we couldn't find any CSV files with the actual data for the statistics. So I decided to go with the web scraping kind of approach there. So I found this website, footballdb.com, and we decided to go with this because if you look at their robots.txt, this tells you if you're allowed to web scrape from it, if you're allowed to grab data. So if you look at user agent, which that's what we are, these are the only pages they disallow, and we were pulling from the players table. So that means, okay, we're good. We can pull from that. So we had say, take Jalen Hurts, for example, we wanted all of the statistics. So what we did is we said, okay, we want these statistics here. Let's go and inspect that page. You can find, okay, this is the row. These are all the stats. So what I did is let's hop over to VS Code over here. Created this web scraping Python script. And I utilized Beautiful Soup requests and pandas data frames basically to grab all of them. So each player URL, as you can tell from up here, has the last name, the first name, and then this little combination. It's like a key. So we're able to create the URL, just pulling our data from our actual SQL database, their first and last names. And we create this URL. And then basically I have this loop here that goes through each URL in our list, and it sends it to this function where first thing you do is you use request to actually send it over with a header that tells it we're a user agent. Then if we get a response, and the response wasn't redirected, that's what that response history is doing. Then we create a soup out of it, a beautiful soup out of it, where we parse it as an HTML. Then we can use that, the find all functions to find the divs and the tables we want out of that HTML. And then so this gives us all the table names, and out of the table names, we want to find all these table TRs for table rows. So all these table rows where this is the name of it. That's what we found in our HTML. Basically, so then we grab all the data out of there, put it into a pandas data frame, right? And then we have the passing statistics, the rushing statistics, and the receiving statistics all in individual data frames. I added in their name here, and then we concatenated all those together, and I returned that one data frame of the big long row for the one player. And then this loops for every player, and each time it adds it to a larger pandas data frame. And then finally, we turn that data frame into a CSV file and export it. And then we can go back to MySQL. We have that CSV file, and we can use that as insert into value. We can insert into our player stats all those values from that CSV table. So that's how we got the stats. There are a few issues that we'll talk about later, but the general overview of our database. And now I'm gonna hand it over to Luke to look at the front ends.
All right, so I'm now going to show off the web app we made to go along with our relational database. So yeah, so our web app is two main pages. One is just a static display of all the teams and their just basic records and head coach. So that's just done with a single status or static SQL query. No like dynamic fields or anything. Basically just selecting everything from team and coach and then joining them and sending that data back to the front end where we can just display it in a table. Super simple. We sorted the table by total number of wins. So you can see over here that Baltimore's at the top with 13 wins and 4 losses. So it goes all the way down to like wouldn't want to be the Panthers this season, or the Broncos and Raiders. I mean, it's just a bad year overall. But that's just our basic display of the teams, and then the main functionality of our app is this find players function. So I'm gonna move my face down here. So you'll see 5 search fields, and then you can submit the search, and then there's also this checkbox. First of all of these fields are optional. So if I just press search with all of them empty, it'll show all the players in our database. And you'll see here that a lot of these players are unavailable. So, or their stats are unavailable. And instead of having like a show button for everyone's stats, I wanted to just own up to like, hey, we weren't able to get everyone in the league's stats. But we did get a lot, so you can check this box to only show the players with stats. Still plenty of players here. And then for each player, you can show the stats, and you'll notice that they're different for every position. So the quarterback has passing yards, passing touchdowns, interceptions, pass attempts, pass completions. Whereas the running back has rushing yards, rushing attempts, rushing touchdowns, receptions, receiving yards. And then on top of that, the tight end, they have receiving yards, receptions, receiving touchdowns, targeted to lost yards. And the wide receivers are similar to that, with yards after catch, as well as the same other stats. So I did this by in the front end, with the stats. I basically just checked every position and then decided which stats to display on our table based on that position. So every player has all of these stats, but if you're a wide receiver, your passing yards are going to be 0. Your passing touchdowns are like going to be 0. All of these are going to be 0. So I didn't want to display any redundant data, especially when it's all just zeros. So that's how I sorted that out. Let's also look at the search functions. So there's 5 main search fields. Let's just go ahead and show all players again. So you can search by division. So say I want to see NFC West. And it'll work if I just type NFC WE. It gets the idea. So here we have players that are, you can see all in NFC West. Now say I want people from NFC West, but I also only want players from the Seahawks. And say I also only want offensive players. Yeah, let's search that. And look at that. These are all offensive players from the Seahawks in the NFC West. The whole division and team combination is a little redundant. Like, you usually only want to fill out one of these because like there's no Seahawks in a different division than the NFC West, so you didn't have to specify that. But still, it's helpful to, like, if you only have limited knowledge of the players that you're looking for, these 5 fields give you a lot of flexibility to try and find them. So say now I just really want Metcalf's. If I just want to look at DK Metcalf, like even though we don't have stats for him, you can still search by last name. And then if I check this box, there's nothing because we don't have stats for him. Other than that, you can search by position. So here's all the quarterbacks in the league. Most of them have stats. So that's pretty cool. Do defense with stats. There you go. So that's another like limitation of our web scraping and just trying to parse all that data into our database, is we weren't able to get like consistent defensive data and just, but I think it works pretty well as a proof of concept that like that we got all this offensive data. So that's about it. I'd like to look at my queries too, just like walk you through how I did it. So the search bars, they're all basically just a form in the front end. You can see here. And then I send all of these back to the back end with a Axios GET request. And then when I get them at the back end, what I do is I have this big broad query that basically selects all the data I could possibly need for a player, or for all players. And then each of the fields is just a little section appended to the end of this giant query. So the main query selects everything for player stats, gets team name, gets position name, division name, and then joins them all together. And we have this where 1 equals 1 so that we can append a and afterwards. So it's not just like a appending an and to the end of like a left join, because that wouldn't make sense. So we want an initial condition that's always true, and then we can append and after that. So then if the team field is filled out, then we want to make sure it's only showing players that have a team name that's like the team. Same for all of these things, but if they're not filled out, it just ignores it, doesn't filter by that. So you only have to fill out whatever you want in the form. I also use the like operator instead of like equals, so that you don't have to type out the full name and it's like complete, like have it completely exact. If you get like a few letters from whatever you're trying to find, it'll find anything containing those letters. So that just adds to the ease of use on the front end. So once again, like say we want the Patriots. If we just type Pat, we're gonna get the Patriots. Like we don't have to type the whole thing. Like if we just type Riot, we'll still get the Patriots because it has Riot in it. So that's just that's how we made it pretty easy to use our app, and that's all the functionality.
So, so you can see that this is our normalization diagram, and so since there are no repeat columns, and also each table is representing a single subject or entity, then it's already at first normal form. And since all the tables have like only one primary key, there's not really any partial dependence. So that is second normal form. And since there's no transitive dependencies between each non-key variables, that means that this is a third normal form database. And we didn't want to, we decided to just stop here so that we won't over normalize, and we don't want to do any denormalization because I think our performance, like this, our database's performance is good enough. We don't have to denormalize to lessen in the joins and stuff. So yeah.
Okay, so now I'm going to talk about some problems that we encountered. First of all, there's a lot of problems with getting the data from the web scraping. There's a lot of little issues. Like, let me show you, for example, first of all, finding the whole reason we did the web scraping in the first place was that we couldn't find a data set online with current player statistics. So we had to go with the web scraping. One of the big problems was this web scraping URL name. So I'm just gonna, oh, sorry. I'm just gonna show you really quick an example of that. So if you look over here, right, it looks pretty standard that each player has their URL is their last name, their first name, and then this key where it's the first 5 of their last name, the first 2 of their first 2 of their first name, and then 01. But you know, when there's this database has like thousands of players, so there's all these conflicts. So you look at like Damian Harris, right? His first name came first, and then his last name, and then he had this code with 11. So I had to do some mapping, right, where I have this dictionary where this is what each parsed URL should look like. But, you know, like for Josh Allen, for example, his was this different key. He was 06. Same for Jordan Love, all this stuff. So that was an issue I was running into, as well as if you look like, let's look at Jalen Hurts, you know, the names of these tables that I have to grab with the soup and I have to find all that data. You know, these ones are called passing, rushing, receiving. But you look over here to Christian McCaffrey, and that's pass, rush, rec. So it's like there are all these inconsistencies. Sometimes players just wouldn't have the pass, and it just started with rushing and receiving. So then that threw everything off because my loop would check like, you know, the spot 0 table, spot 1 table, spot 2. So if someone didn't have it, it would throw everything off. So those are some issues with the web scraping. We were able to get around most of them, but I think that probably contributes to why a lot of players don't have data. But we did the best with what we could, as well as a lot of the fields when we scraped were capitalized. So if you look back at our database, like for player stats and you go to columns, these are all capitalized, even though in theory, you know, it's good practice to have these not capitalized. So and then Luke was like, you know, he was trying to do them with lowercase. So then we were running into problems there because we were just having key issues, but we figured all that out. So those are some problems I ran into.
So let me talk about like the result and impact of our project. So by offering like a user-friendly interface and an extensive collection of data, we have enabled users to gain a deeper insight into player and team performances. And this access to a detailed statistics has enhanced the overall understanding of the game and fostering informed discussions, and enriching the fan experience. And once we have elevated our database, which we will talk about later, there it could also be possible that it can like expand to like a business side of impact, where sports media outlets and journalists can use our platform to gather information for their reporting and enhancing the quality and depth of their coverage.
All right, so some future directions we would be able to take this project is, first of all, we'd want to host the database and the front end. I'm recording this on Thursday, March 14th, so there is a chance that by the end of next week this is hosted. I would like to look into doing that. That would actually make it into a accessible website. And then it also has good potential for being ported to mobile, but for now, I think it's fine that you can just access it on your like mobile browser. We would also just improve UI design. Something I do like think sets us apart pretty well is just the like pure simplicity of like our UI, because a lot of these other NFL database websites you'll see are just super cluttered, and it's kind of hard to make out like what you're actually seeing. And they have all sorts of inconsistencies, like Jack pointed out on the football database website that we were scraping from. So I like where our UI is at, but we could add a little branding and whatnot. It would also help to just include more information about the players and teams, like pictures, graphs, whatnot. I also think it's worth mentioning that in our database, we do have data on every single game played throughout the season. But on our web app, we do not have that displayed simply because um, we were informed that the scope of our project only had to, like, we didn't have to do all that. We didn't have to display all those games. But in the future, I think it would be a great thing to have, similar to our player search functionality, just have like a game search or just a list of all the games in each week. So that's another place we could take this app if we wanted to further pursue it. On top of that, we could import statistics for all the players, including defense. That's just, I mean, it's just dealing with more web scraping and data collection. And yeah, we could also update data for any changes in the league. Like this week, a bunch of people have gotten traded for the upcoming season. And our database does not reflect that because it's not updated in real time. And then, yeah, we'll just all talk about our own contributions to the project. So I mainly developed the business rules in the ERD, and then took that ERD and put it in SQL just to make like the actual data tables. I did not do any of the populating of data. That's out of my pay grade. But I did do the web app. I used React and Express, and was able to connect it up to our local hosted database and execute SQL queries from the front end, and it worked like a charm.
Yeah, I started out by taking Luke's he created the tables, and then I started populating all that. So I started by finding CSV files online with current data that I could use to convert into insert statements that would match all the data. So I did that, and then we did a lot of that. And then for the player statistics, the web scraping took a lot of time, leveraging Python and like the request library. First of all, I was trying to use Selenium, but that was just a big headache because I kept getting blocked by the website. Also, doing the due diligence of finding a website where we were allowed to scrape from it, because a lot of websites, you go to the robots.txt and you're blocked from everything. And then using Pandas data frames, that was another big aspect of the web scraping, along with, of course, Beautiful Soup. That's what really powers all that, getting that HTML, finding the tables you need, finding all the rows. That took a lot of time, and then trying to get that data into something we can use and something we can display. So that's another part I contributed. And then yeah, and then you want to go ahead?
Yeah, so I just took like the tables that Luke made and then turn it into like a normalization table, and also like just trying to like find like any kind of dependencies that exist in his table, and then just talk back to him about it, and then edit it back into our ELD and our SQL. And then I just took everything that we did and then just put them into this presentation. Yeah. And I think that's about it.
Yeah, I
Yeah.
think that's all we have. Thank you very much for watching our presentation, and hopefully we'll get this hosted and you can find all the NFL data that you want.
Yep.